Hi, in this video I'm going to explain a problem about electrostatic force, electromagnetic force. This problem states that there are two spheres. They are hanging from a string. Each string, well, it's a kinetic string, and in this case, each side of the string will have a measure of 45 centimeters long, and um, that, well, these are the spheres. This has a length of 45 centimeters, and a charge is added to each one of them, and they repel. Um, and when they repel, an angle of 10 degrees is formed between them. Um, and the question is, what is the charge of each sphere? Well, we know that in this case we have four forces, well, three forces acting on each sphere. If this was the diagram of each sphere, we have the force of gravity going downwards, the, the force of the electromagnetic force over here, uh, below, over here. Being repelled from the other charge, and then we have a tension over here. That's the tension of the string that is hanging. And then if we separate this force of the tension, we would have, I'm gonna erase this one. We would have a force of the tension in y and a force of tension in x. All right. In this case, we know that the force of the tension in y, it's the force of the tension in this tension multiplied as it is the opposite angle, well, the opposite side, it will be by the sine of theta, and in this case it will be force of the tension cosine of theta. Alright, so here we have a system of forces in which the net force of that system is zero. So we can say that this force is equal to that force, and this force is equal to that force, and that should be helpful for us to be able to answer this problem. So that said, we're gonna start by solving this equation with the system of equations, comparing the force of tension in y, it's equal to the force of the gravity, which is equal to the mass times the gravity. Mass times the gravity. In this case, we know that the mass, it's equal to 2.33 grams, that is equal to 0.002 kilograms. 33 kilograms. If we multiplied that times the gravity, we would have a force of 0.0228 newtons. And that it will be equal to the force of tension times, in the y-axis. In this case, we know that the force of the tension in the y-axis is equal to the force of the tension times sine of 10, which is equal to 0.0228 newtons. So if we divide that I'm completely lying. This is this cosine. This is the sine, and this is the cosine. Why is that? Because here, this is our angle. This is our new angle. So this is the complementary angle of that one. And since what we're observing in this type of problems is the charge and not the like this point where the string is coming, so that'll be our angle, and using that, then we know that that's the adjacent side of the triangle. So that'll be our cosine. So that's cosine of 10, which is equal to 0.02315 newtons. So I'm gonna leave that number there, and let's remember that that's the force of the tension. And if we now compare, well, use that value to our other system of equations, that is the force of the tension in the x-axis, it's equal to the force of electromagnetic force, then we could use that value here to obtain the value of the force of the electromagnetic force. So we're going to use 0.02315 times the sine of 10 equals the whole expression of the force, electromagnetic force, that would be the constant k multiplied by q1 multiplied by q2 over the distance between them squared. In this case, we'll make a small pause to solve that r. The distance between them is over here, is from here to here, and that'll be r. In this case, we will solve it again using a triangle. We'll solve it as 0.45 multiplied by the sine of 10, which is sitting in the ground, and this is hurting, which is 0.078, and we will multiply that number by 2 because as you can see, this will be only half of r, and as we want the whole r, the whole distance, we'll multiply this by 2, which gives us 15.1562 meters. So we'll use that value over here, and it's 0.1562 squared, and as q1 and q2 are the same, those can be expressed as q squared, and we know that k equals 9 times 10 elevated to the 9, and then if we solve that, passing this dividing this and this multiplying this and the square root of everything that goes over there, we would have 1.04 times 10 to the minus 7 coulomb.